Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm Peter Ballant from Technicon, and today we look at the certMILS project once again. As you recall, this EU-funded effort is researching ways of keeping complex systems safe and secure. The last time, we talked about trains and power grids that could benefit by rapid and efficient safety certification methodologies. That's the goal of certMILS. Using the existing MILS, or multiple independent levels of security platform, certMILS seeks to find ways of shortening, simplifying, and implementing new certification methodologies with the ultimate goal of efficient security in embedded systems across Europe. Today we speak with Holger Blossom from Cisco and Thorsten Schulz from the University of Rostock, also in Germany. Both gentlemen are project partners in certMILS. They join us remotely from their home offices today. Welcome, and I'll ask you, Holger, what is certMILS and where does the name come from?
So the idea of certMILS is that we demonstrate how to certify modern embedded systems that are safety and security critical. So these are also called cyber-physical systems. And that to do this, we not only say that we certify, this is where the cert is coming from, but we also introduce that we intend or that we do apply a certain methodology, which is by using MILS systems. MILS itself means multiple independent levels of security and or safety. And maybe MILS is something that needs some explanation. And actually, the easiest way to explain MILS, in my eyes, is to start with what we everybody know. That's operating systems and computers and how they relate to our everyday life. So if you're sitting at a computer desktop or laptop, then you probably want to use that computer, which is itself a fairly general purpose machine, to do different tasks. At your desktop, there might be, you want to surf the internet with your browser, you might want to have some document editing, you might have spreadsheets, you might have things like teleconferencing software, you might have some drawing software, and you have this different task of telecommunicating, drawing, writing text, writing structured data in spreadsheets, and so on. And you have different applications for that. That is, on your desktop or laptop, you have an ecosystem of completely different applications that were also written by different teams, and everybody was doing the applications at getting what they are really good at. Say, for instance, for the internet browsers, for surfing the internet, you can even choose among, say, Firefox, Chrome, Edge, and many others, or Opera, to name a European company. And again, for the document editing, you could choose between, say, Microsoft Word or LibreOffice Writer and things like that. And you have different tremendous teams behind all these applications that in the background or that do their job when you need them. But you can also have different applications open at the same time. And then magically, even if you're using a teleconferencing system and you're editing a document at the same time, maybe a document that you're showing and maybe you're browsing at the same time, these applications usually do not interfere with each other. They do not get into each other's way. I mean, sometimes they do, and then on the desktop operating system, we notice, oh, the system is frozen. The spreadsheet is calculating, and I can't use the browser, or vice versa. But it's not happening that often. And the magic behind this, that these applications that have been developed by completely different teams, by great teams that were optimizing for their own things, that they don't interfere, that's the operating system. And the operating system is in charge that you can run these things at the same time, or seemingly at the same time, on a single computer without interference and magically having aligned these things. Now, next, I go to things that we don't see in everyday life that often, but we are going to embedded systems. Embedded systems are things that are deep inside the magics of everyday technologies. Say, of last time, Sandro and Thorsten were talking about trains, and it's about the control systems of trains themselves within the trains. It's about the control systems of interlocking systems that allow where the trains are run. And again, these traditionally have been very, starting in the 1970s, 80s, 90s, very simple devices, and they are now becoming networked to the internet because that's useful for monitoring them. So if I'm talking about these embedded devices, some frequent quote applications or needs that we see is that we have to run a control on such a device. It's also called an actuator, that we say, brake, please now brake, stop, or kind of release the brake again. Or that we say the signal shall go green or red or whatever. So this is part of this is that the embedded system is actually controlling a device. A second common pattern that you have in embedded system is that you need some remote monitoring of the thing. That an operator of, say, several thousand interlocks on a railway grid can see the overall state of each interlock. Is it open or is it closed? And remotely also inspect the kind of health status of the device. For instance, does it react properly? Maybe it's getting rusty or whatever. Thirdly, that was also a talk that was also talked by Sandro and Thorsten last time, is the important is the need to have updates of the system to react to security challenges, and this. Well, there are different ways of doing this. This either can be done locally by a trusted operator, doing in the traditional way, coming with some USB stick or something like that, doing an update on site, or you do it remotely. If you're allowed to do it remotely, then again you have quite strong security requirements that this update function does not interfere with the monitoring and the actuator control. So coming back to the original topic of interference, again, on this embedded devices, it's very important that these applications do not interfere with each other. So that, say, if somebody is monitoring the status of an interlocking signal, it should never interfere with the actual functionality of giving a signal of the interlock or a braking system. It must never interfere with the braking itself. Therefore, we need, for an embedded device, we need an operating system that is really, really reliable in keeping these different tasks apart from each other. The concept is the same as described on the desktop operating system or laptop and the mobile device, but here on the embedded device, it's an absolute priority that the actuator, that the control is really executed within, say, 10 or 50 or 100 milliseconds within a defined range, and that it is not just 99% reliable, but close to 100% reliable. And this is the ecological niche of certain kinds of embedded operating systems that are called MILS operating systems that share many design principles with the general purpose in the operating systems, but as a special feature have that they have a strong emphasis that they were designed to keep the applications apart and also to allow for some more static configurations. And usually these systems are more simple than desktop operating systems. MILS separation kernel is 1,000 times smaller than, say, Windows or Linux or the big operating system, so that you can make a really thorough and deep analysis of it and have a better understanding. So it has less features, but also less complexity, and is suited to this kind of embedded systems that have comparatively still simpler functions than a desktop operating system, but that conversely do very critical things that must not be interrupted or interfered with.
So that's a great analogy, using a desktop operating system to sort of illustrate the importance of things working together. And it sounds to me like in certMILS, this is the goal. Things have to work together, and there really can't be any mistakes. And there has to be some kind of certification that says these things work together. Am I seeing this in the right way?
Yes, this you're actually bringing up the second four letters of certMILS. So far, I had only explained the MILS acronym, and now we can go for the cert, for the certification. So what in the end is certification? So certification is, in my eyes, that people construct an argument why a system is secure, why a system is safe, and that this argument can be inspected by different people, and then they can agree on this analysis that the architecture, that the design of the system that is being certified is safe and secure against, in safety, random faults, and in security, malicious attackers. And now we can maybe bring the certMILS together. So now I gave a general view on certification, and in one of the MILS workshops where we're talking a lot about certification, because Peter, as you rightly said, certification is important for this kind of critical systems. That was actually 5 years ago. Katarina Netkachova made an argument about security cases. So these are structured arguments how to present the security of a complex system.
Okay. And Thorsten, I want to throw something out to you. We talk about embedded systems.
Right.
What is the likelihood that the average person on the street encounters an embedded system? Is this something it's part of their lives, or is it something that maybe they have never been in contact with?
I think for most of us listening to this podcast, like everybody that's listening to this has been in contact with an embedded system. So just in the morning, if you walk past, like one of the earliest ones that we name embedded systems, basically also been washing machines and basically any device that you mainly physically interact with in your home environment would be that what we consider an embedded system. So because of the physical interaction. But then also for home devices, as Holger just on the other hand, Holger just mentioned the certification. So we also have that for home devices. So our home devices, like our toaster, doesn't get mad at us just because we plugged in the piece of bread the wrong way. So there's certification that they do the right thing, but there's typically more strict certification going on with systems that can harm not just one person, maybe just scratch their finger, but we had the larger infrastructural systems where you can harm hundreds and thousands of people. So that's a bit of a different embedded system category that we're talking about. But yes, I think basically everybody has been in contact with what we call embedded systems.
So we could say that they're everywhere. They're ubiquitous. There's no getting around embedded systems for anybody, basically. Right,
correctly. So even like I was thinking, I was just walking outside of my home, would be the first thing to see would be a traffic light. It's part of the infrastructure. Also, it's maybe hard to say that it's embedded system because it's actually sticking out of the ground. But this is exactly the things that we interact with every day and that we rely on with our integrity of our health and our body, right?
I was thinking about probably the battery controller in an e-bike is already an embedded system. Then you have dozens of processes in any car. If you're going by train, you'll also have dozens, if not hundreds, of processors in a train. Airplanes have a lot of them, so they're really, regardless of the way of transportation that you use, relevant for you.
And tell us about the certMILS project as it sits today. Let's sort of take the temperature a little bit. How long of a project is this?
It's a 4-year project. We intentionally made it long because we anticipated that certification takes time. Certification is a communication endeavor, and therefore it's not only us who can do things, but we also have to talk with certification authorities and also the people making the certification standards.
Okay, it makes sense, yes. And so it was deliberately made to be a long project, a 4-year project. And how far are you at this point?
From the timeline, we are in the fourth at last year. Actually, with certification, it's sometimes hard to give exact timelines because it's a little bit, maybe can be likened to a legal dispute as a court or something. So the parties have to agree that the argument is sound, and that may take all the time it needs to take. Therefore, I would say we are in good progress, but it's particular for a certification project, it's hard to give an exact metric saying we are now at 78% or something.
And Thorsten, for you, at the end of this project, how do you know it's a success, or what will make you happy at the end of the project and in a position where you could say, yeah, we've done our job?
So looking at the certification that Holger just mentioned, so if that goes ahead, I mean, it always takes a little bit longer, and we're also starting to see very small delays towards the end of the projects, which we basically did foresee. But since we're heading for the final months of the project, and we still have the timeline that we're gonna get the certification goals that we wanted to achieve, and we're really looking forward into achieving that towards the end. Maybe a few weeks after, we'll see how the external authorities can work with the whole workload and the situation of other workloads that they have to face. So once I can see all the certification artifacts being passing by official grounds, and this would be the one achievement, and the other achievement would be to see the architecture and the methodology that we set up to actually be also used beyond our own project partners, so in other systems and other designs around the world. So if we can see that, then I think we really achieved something. So I mean, it is a EU project, and we're really striving to have other partners in the European Union involved in this, also beyond our project partners. But obviously, we're also happy to export that methodology and the way it's been done worldwide. So we have been just, even though this was a finishing sentence for you, but we also been reaching out to other companies and programming and system developers, system designers around the world, for example, also in Australia and in the US. And we're quite happy that we got positive feedback on our methodology and the certification process that we're doing. So already this has been quite a little bit of success for the projects, I guess. Yes. One of the reasons that the EU is funding this project is also to get a methodology and get kind of almost a unity on the certification approaches to make it successful and more usable for a lot of users. So I mean, the whole European Union also depends on exporting technologies and worldwide use. So if it's just us 10 project partners using their technology and approach, that's not much worth. But I mean, it's something, but it's really important to get the technology and the approaches being used by other vendors and partners in the market. So, and I'm quite happily looking forward for that. Yes.
I mean, another outlet that I could make some shameless advertisement here is the MILS community. which is mils.community, and this has an open mailing list that everybody can subscribe to discuss MILS topics, and we have been doing several public MILS workshops where also results of certMILS have been presented and shared.
And this MILS community, this is not a project. They're always there, right? It's ongoing.
It's ongoing. So it's, I don't know when actually did we start, 2015, but at least well before certMILS.
Why is it that the European Union would decide to fund a project like this?
So I think there's two perspectives of this. So from my understanding, almost seeing it from the user perspective, like in the other podcast, we discussed about that we want to have the technology and we want to have it working and we want to have it also reliably working. But on the other hand, so we need to have all this certification for our products, but with the new requirements, so you can't stop people from saying like, I want my trains or my smart grid to be smart. I want, for example, my airplanes to be on time and all these things. So like there's the demand for that. And we basically, with all the security measures that pop up, we have to run behind it and to keep things secure, to actually keep them safe. So all that we want is we don't get harmed. We don't want to be injured or anything. So we're at this very moment, we're basically running behind security protecting things that are being kind of smart inter-networked and things. And the idea or the concept of the European Union funding these kind of projects is to get behind these issues, to keep things secure and safe, also for the critical systems, and not rely on maybe on that there be someday some solution from somewhere else in the world. So we want to have that technology within the European Union, and we want to have it as soon as possible before we get hacked, as we discussed in the other podcast.
Okay. Well, I have to say thank you. You guys are doing the work that's sort of behind the scenes and very important in our society to keep people safe and secure in their daily lives. So this project goes a long way to ensuring our safety and the safety of everybody listening. So thank you for doing that, and good luck with the rest of the project. And we may check in at the end to see how things are going and how the wrap-up went. So best of luck to you.
Okay, thanks.
Thank you, Peter.
For more information about certMILS, visit their website at certMILS.eu. This podcast has been brought to you by Technikon. The certMILS project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 731456.